Good afternoon, everyone. It's glad to be here, and today we're going to explore a critical yet often overlooked aspect of security, and that is our topic, the illusion of isolation, how isolation failures in CI/CD servers lead to RCE and privacy risks. And let's begin. So I am Tianzhou, and this is my partner, Yiwen Wang. And it's a pity he can't be here. And we are students from University of Chinese Academy of Sciences. And we played CTF at Never Stop Exploring, aka NESE. And we do web security research. So here's the outline. And before we jump into technical details, let's first understand why CI/CD security is an urgent issue today. So this pic illustrates a typical CI/CD workflow. So the dev writes code locally and commits and pushes to the remote. And the code then goes through the run, tests, and build stages, which are part of continuous integration, also known as CI. And afterward, it undergoes the publish and deploy steps, which are part of continuous deployment, and that is CD. So these steps are collectively referred to the CI/CD pipeline. And CI/CD platforms can be divided into two main components. One is the server side, and the other is the worker side. So they often maintain a one-to-many relationship. And the server side usually takes on more responsibilities, like integrating with SCM, audit log of changes, design your own pipelines, and send command to workers, and maintains build records. And for workers, or you may call them agents or like runners, so they are all the same, and it can run on any OS. And their job is to run jobs in the pipeline. And that could be a machine or a container or a pod. So that's for worker. And by default, server configure jobs and let workers finish them. So that's how the pipeline works. And workers and servers are usually isolated by physical mechanisms, physical machine boundaries, or container mechanisms. So we introduced the concept of isolation mechanism. So the isolation mechanism can be divided into two dimensions. So first, at the file system level, you see that command executes on different machines for server and worker. And code may be built in isolated containers. And code should be separated in file system level. And second, at the data level, server and worker are isolated by physical boundaries, and projects are built in isolated virtualized environment, and projects implement access control through RBAC policies. So it looks like all CI/CD functionalities follow the isolation mechanisms. So server do server's job, and worker do worker's job. But is that really the case? So let's see if flaws of isolation mechanisms lead to security problems. Let's take a closer look at the most common vulnerabilities found in CI/CD environments. So in a typical CI/CD environment, an attacker usually has multiple ways to target different components on the platform. Like attacker can gain access through a weak password, or it can get access via a supply chain attack. Or they can search leaked secret across from cloud platform. One famous way to attack CI/CD is called the poison pipeline execution, which is PPE. And attackers may inject malicious code into code repo and inject malicious code. They pull it into a pipeline configuration and essentially poisoning the pipeline. And they have access to worker machine by leveraging the PPE. And for the dependency chain abuse, which is also another common way to attack, is also known as supply chain attack. An attacker may upload a malicious package to public package repositories and execute code during the process. And when performing penetration testing on a CI/CD, we still need to follow the standard approach. So let's start by recon, then initial access, lateral movement, and persistence. But if you notice that these common attack paths we just mentioned earlier can all be used in penetration testing, but only able to gain initial access. So it is actually worth notice that we only have access of worker instead of server. And also, CI/CD pipelines typically provide you with the opportunity to execute commands in worker directly. So in most cases, attackers get a worker shell as an initial access, and they only have access to limited resource like code, repo, and secrets, and they still need to do lateral movement, container escape, etc. So here comes the motivation. Can we find more vulns on the server side with the help of isolation mechanisms? And our goal is to execute commands on the server side, not the worker side. So to achieve this goal, I will introduce a key feature in CI/CD, which is called SCM, the source code management. So the SCM and CI/CD form the foundation of modern software development practices. And CI/CD takes the code managed by SCM systems and automatically builds, tests, and validates it whenever changes are pushed. So your code is processed by CI/CD and may cause problems not only in worker side because server takes the job. So what makes SCM a great attack target? So the first attack surface is that the repository is often configured by users that use CI/CD. So parameters such as the repository URL or branch are attacker controllable. The second attack surface is that SCM needs to interact with the repo. So it might use the client and execute corresponding commands. So there are chances of command injection or parameters injection. The third attack surface is that an attacker can fully control the content within the code repository, like we can put anything on the GitHub or GitLab. So if malicious files are stored on the target machine, it may be possible to chain with other vulnerabilities for further exploitation. Okay, so now you should know that SCM is dangerous. Can we use it to find more vulnerabilities in CI/CD? So let's start with some interesting cases. To illustrate this risk, let's examine real-world cases of CI/CD. So my first target is called Bamboo, which is a CI server from Atlassian. And in Bamboo, they use plan to define like everything about the continuous integration build process. And plan can be divided into stages, and stages can be combined with job and tons of tasks. And they also have a concept of repository. So a user can create a repository like Git repository or SVN repository and link it to a plan. They also have a configuration as code feature, which is called Bamboo species. So storing your build plan configuration as code for easier automation, change tracking, and validation, and much more. And that's what Bamboo species do. So what does the process of Bamboo species look like? So first, it will fetch code from a remote repository, and then scan the repository and checks for a directory named Bamboo species. So if Java files are presented in this directory, it will run some Maven build in Docker container. And if YML files or YAML files are present in this directory, it will scan the YML document. And in the end, both ways lead to Bamboo plan creation. So you can see that it uses content from repository to create a plan, which is CI jobs defined in Bamboo. The YAML solution is concise and clear. You just write down YAML lines. And for Java species, it allows you to write code, Java code, to create a plan, and it provides greater flexibility. So how does Bamboo species scan for a file in a Git repository? The answer is simple. It will clone it to local, and the local site, which is exactly the site that the server assigns. So here's the key code related to Bamboo species. So the repository path that is cloned to the local consists of a fixed string. and the repo ID, and branch name, and other components. And the repo content will be checked out to a directory named checkout and got deleted in the end. So this looks like a temporary resistance of a code repository. So instead of configuring plan manually, Bamboo allows the user to clone a repo to the server. And this lacks file-level isolation, meaning that the contents of the repository reside on the same machine as the Bamboo server. So let's see what we can do. The first vulnerability we discovered is an arbitrary file read vulnerability. So from the code, we can see that it uses a method called read file to screen to read file content. And it will use it to read a file named bamboo.yml from the repository and parse it with snake.yml. And when the parse stage is finished, it will convert it to a Bamboo plan. So a simple idea is, why don't we create a symbolic link named bamboo.yml and point it to @c password? So when it got cloned, Bamboo will read it, and let's see what we can achieve. And why the idea that we use a symbolic link is because Git determines whether to create symbolic links based on the core.symlinks option, and the default option is true. And also, these symbolic links appear as plain text containing the link file when viewed from the remote Git server frontend. And when parsing YAML, we just mentioned, so the exceptions are caught by an outermost catch statement in the code. So an exception is thrown during parsing because we use the @c password content instead of a regular YAML content. But the exception message contains the contents of the sensitive file we just point to. And the CPG scan will log this exception. So sensitive file content exposed. And we also find another example that Bamboo supports a code source named perforce. When creating repository, it may take environment variables as input. This is quite understandable because perforce itself, the client side, requires various environment variables for configuration. And so the Bamboo lacks validation for environment variables that a user can input. So we are actually gaining an environment variable injection when use the test connection ability of perforce repository. Okay, and here's some code from the perforce client that Bamboo uses. So it will actually attempt logging when current response message indicates that the server requires login. And Bamboo itself will invoke a Linux command by binsh. And since we have an environment variable injection, why don't we use a famous environment variable injection technique introduced by other researchers, which is using a environment variable starts with bash underscore func underscore, and you can actually achieve code execution during any bash command execution. But here, our command is actually invoked by binsh, and in that case, this bash underscore func environment variable injection technique can only be used at CentOS. So can we make it more universal? The idea is simple. We can still use the old but decent LD preload technique to make it work, but only if we had a way to upload an evil dynamic library, which is an .so file, to the target server. And remember our Bamboo species repo? The repo content will be cloned to the server, so we actually can place this dynamic library in a GoCD repo, and Bamboo will clone it to local, and we can use it for LD preload. So the steps are clear. So first, we prepare a remote repo with evil SO, and use Bamboo species to check out the repo on the server. And then we create a perforce repo and specify the LD preload environment variable and click test connection. Oh, seems that we have an RCE, right? But how do you determine the absolute path of a checkout repo? And how can an evil dynamic library persist on this target server? without being deleted, because we mentioned that the code repo will be deleted after the Bamboo species, right? So for the first question, let's go back to the previous code. We can trace the YAML parsing logic. So here's a function call of split document, and it actually initializes a YAML code called getYAML with repository includes. So what does this include means? So I find out that the snake YML that Bamboo use actually supports include tag feature. So you can write a include tag in a YAML. And during the parsing, a path traversal check will be triggered by Bamboo. So it will actually throw an exception message with the absolute path of the YML directory included. So which is exactly the path under the cloned repo directory. So if you prepare two YML files and include one of them using the traversal path, it will actually trigger the exception we just mentioned. And this exception message just contains the absolute path info we need. And you can see that that is the absolute path of the cloned repo. And so the first part is the Bamboo data directory, and under below it is a checkout directory and also the repository ID. So if you have this path, you know where the dynamic library file persists. The second problem is that the repo will get deleted after the species scan is completed. So how can we persist this file? Race condition is a simple idea, but it's not elegant enough. You need to raise two threads continuously. So any other ways to persist this file on the target server? Remember Bamboo Java species we just mentioned. It will actually run Java code in an isolated Docker container. So we can't achieve code execution in Docker container than to the server side. But we can call simple methods like thread.currentThread.sleep. So we can just sleep for a while, and we drag this species scan process for like about 60 seconds, and the files won't be deleted during this stage. So if we add the step of obtaining the absolute path on top of the original logic, and we continue the steps we just mentioned, and we have a RCE technique. So RCE by LD preload is great, but the perforce executable may not be installed by default. So we do not have an environment variable injection by default. So we still need to find other ways to RCE. And in Bamboo, there's a section called branches for CI plan. And let's see how Atlassian described it. So plan branches allow you to run builds across different branches in your source repository using the same plan configuration. So users are allowed to create branches and run specific branch during build tasks. So here, different branches represent different branches of the repository to which the current plan owns. And also, there's a merging option that aims to automatically merge changes from the team's master branch into your feature branch. So Bamboo will actually merge from a given branch and push on the feature branch. And this branch means the repository that is linked to a given plan. And the whole process happens during the run branch option. And that's how you run a CI job as well. So let's see the code related to the plan branch. The build tasks are split into different stages in the code and exist in the chain form. So first, you will check branch integration option is enabled. And then it will call a method called VCS merge. And lastly, the push the merge commit method will be invoked at the end. So in the do VCS merge runnable method, we found that there will be a git merge command. You can see that here's a merge and update result method. And for the push the merge commit runnable method, it actually has a method call for commit local and another method call called update remote. And the previous one refers to a git commit command, and the other one is a git push command. So merge, commit, and push. And that's what the CI job do when you apply the merge option in a CI task. And this seems like regular operations of Git commands. And what potential threats does it pose? So we are introducing server push attack here. When talking about remote repo, we assume it is operated on remote server. So what if this remote repo is actually a local repo? So normally you perform git clone to get a working copy, and then perform git add, git commit to get a local repo. And finally, we push the local repository to the remote repository using git push. And that's the normal Git workflow. But you can actually clone a working copy from a local repository. So almost all other operations are the same, except that we are using the file protocol instead of the HTTP protocol or SSH protocol. So does it expose potential risks? I will first introduce the concept of Git hooks. So Git hooks are scripts that are triggered by certain actions in the software development process. And by automatically pointing out issues in code, they allow reviewers not to waste time on and that can be easily diagnosed by a machine. So Git hooks can be divided into client-side hook and server-side hooks. And hooks executed during client operations belong to client hooks. And those executed during server operations belong to server hooks. So for example, the pre-commit hook, which is used to inspect the snapshot when you before you commit a message, and that will be invoked, and it belongs to the client-side hooks. And you can check your own Git repo, and you will find hooks files waiting to be edited. And simply remove the .sample extension of these files and modify the file content, and you can make the hook works. And it will actually give you ability to execute arbitrary command when Git command invokes. So let's back to our Git workflow. So we have a pre-receive hook, which is a server hook. Suppose we have it on the server side, it should execute on the server side. But if we specify the pre-receive hook in a local repository, and when it got cloned, and we push it from a working copy that we just cloned, the hook will actually execute on the client side instead of the server side. So, and that is because when calling git push, git receive command receive pack, this subcommand will be invoked by the git process. And by default, it uses SSH and HTTP protocol. But if you clone from a local machine, the git receive pack will be called when pushed from a local repo. Then the hook script will be invoked on the same machine. So that means that explains the client-side execution. Okay, so if we specify a repo through file protocol, we can trigger a server hooks on the client side. And this is the core of the server push attack. And it seems feasible, but how we don't have a local repo or target server. And Git hooks are not controllable in a working copy. So we still need to write things into hooks directory under local repository. And is that really the case? So actually, we have a Git repo that shows some Git magic. So if we follow the steps that this repo tells us, so first you clone it to a local, and then change to a directory named evil git directory. And if you execute a git checkout master command, it will actually print something saying that arbitrary evil code goes here. So if you check the post-checkout hook under the hooks directory, you may find the exact content that we just saw. So the post-checkout hook got executed, but why? Let's take a look at the evil git directory, which is on the right side. You can see that it has some directories named hooks, info, and logs. And that's what we called a bare repo. So a bare Git repository is intended to be used as a remote repository where code is shared between members of the team. So the bare Git repository is not intended for local development, and you may see them on Git servers. But the example that we just saw shows us that it is actually possible to put a bare repo in a regular Git repository and host it on the remote. So all the files will remain the same structure when cloning to local, including the hook scripts. And the hook scripts are ready to be executed through Git commands. Okay, so the Bamboo species allows us to place a repo on the server and got hook scripts prepared. And it can also be used to link the repo path and combine with the run branch functionality, which you can push to a local repository via file protocol. So if we combine them together, we got RCE. But just to mention that Bamboo species require user with repo privileges, and the run branch job requires user with plan privileges. So we have a bonus vulnerability, which is privilege escalation to escalate from a repo user to a plan user. And that is because permission is incorrectly set to system during the Bamboo species process. We can use it to overwrite any configuration of a given project. So by combining all these steps, we finally achieved RCE. And here's a screenshot of the command execution. Okay, so the Bamboo case teaches us that certain SEM-related functionalities may overlook file isolation. So repository operations being performed on the local machine and resulting in severe security risks. So do we have any more cases? Here we have GoCD, which is a free and open source continuous delivery server. You can use it for pipeline visualization and deployment management. And GoCD has a feature called Create Configuration Repository. And it will load a configuration file from a remote repository, just like Bamboo species. And additionally, GoCD stores all critical server configurations in an XML file, allowing admin users to modify the configuration by directly editing this XML via the web interface. So by default, configuration repository parses a JSON file or a YML file as input. However, it also parses the XML file, which the documentation did not mention. And actually, the XML parsing library is vulnerable to XSE. So if you edit the plugin ID to GoCD-XML, you can trigger the XSE in the admin configuration XML section. And even the developer himself do not know about this, the existence of this XML plugin. Remember the arbitrary file read vulnerability we mentioned earlier? We also tried it here, but didn't work. So no chances of using symbolic link to read file contents by YML or JSON. But we are still capable of leaking the repository path via a mail form JSON. And actually, GoCD stores all repositories used in pipelines as bare repositories in the flyweight directory and assigns them UUID directory names. However, if an error occurs during the repository checkout process, the files in the repositories will be retained. So no file isolation again. So my first thought was to find another feature to change the vulnerabilities for exploitation. And not that hard to find the backup script settings that can execute scripts on the server. So if we specify the post backup script as a prepared malicious script in the repository, we will gain the ability to execute arbitrary commands. So RCE again. With all the vulnerabilities we found, it's pretty impractical if these vulnerabilities require admin privileges. But we can still find a privilege escalation to make them valuable. So in GoCD, it actually uses JRuby, so it can handle some logics through Rails app. And by default, you can access the admin routes as a regular user, and we can't access the admin functionalities that we just found for exploitation. However, it is possible to directly access these handlers by Rails routes without permission check. So if you access it through the Rails routes and update the config XML we mentioned earlier, and you are admin now, and you can make all these vulnerabilities we just mentioned valuable. Now let's look at the next target, OneDev, which is a Git server with CI/CD, command, and packages. So in OneDev, steps are defined in jobs to execute scripts on designated images. And let's take a look at the CI/CD steps that OneDev owns. So you can actually execute system commands directly through the execute commands step in OneDev. But if you try to run it other than a Docker container, it will actually print out error messages. And that's because system commands can only be successfully executed within the container by default. So it actually effectively isolates the server environment from the worker environment. So have other CI steps also correctly implemented in isolation? Our first discovery is in the pull from remote step, which performs a git pull operation from a remote repository. In other words, it executes the git pull remote URL reps command. And OneDev also has a validation on remote URL, saying that only HTTP and HTTPS protocol is supported. But it can be bypassed by editing a YAML file named .onedev-buildspecies.yml. And that YAML file aims to set up all the CI/CD steps in a repository. So in reality, we have a parameter injection here. And you can achieve this parameter injection through the --upload--pack option and bypass several validations performed by OneDev. And that's the payload, you can see that. The second discovery is that OneDev is also vulnerable to the server push attack we just mentioned for Bamboo. That's because OneDev clones the repository into a local file system and mounts it into the container that it uses for CI tasks. So instead of cloning directly into the container, it just clone it to local file system and mount it. So that's because he does not require user-supplied images. But this operation lack of isolation between repository content during checkout and push. So there's also a lack of restrictions on allowed Git protocols and randomization for repository paths. So you can actually use this file protocol to point to a local Git repository. And you can also get the absolute path easily and indicates that where the Git repo clone to locally stays. So first, to exploit this, we need to prepare a malicious repository and use the checkout step to keep it on the server. And next, we create another job and use the push to repository step to push to the repo. And combine them together, we have a RCE via server push attack. Okay, so the last case is for GitLab. We also look into GitLab runners and find that it implements different executors that can be used to run your builds in different environments like Shell, Docker, Kubernetes. And unfortunately, when you use the shell as the executor, GitLab does not provide effective data isolation to protect your project. So projects from different users will remain on the same runner. And attackers simply use the ls and cat command can access other users' projects, even if the projects themselves are private. And GitLab, Bamboo, GoCD, and OneDev all offer similar solutions for runner deployment, including shell and Docker options. However, none of them provides sufficient data isolation in the shell-based solution to ensure that different users does not expose their data when using the same runner. So we recommend that users choose the Docker-based solution when setting up runners to ensure the data security. And here are the lessons that we learned from these cases. The server side can be just as vulnerable as the worker, and always isolate your code from critical infrastructure, and always isolate user information from other users. And lastly, always process code on the worker side when executing the pipelines. And that's the final takeaways. There may still be overlooked attack surfaces in the functional implementation details of CI/CD servers. And the absence of isolation mechanisms can lead to serious consequences. Lastly, cloud-based SaaS has a natural advantage in implementing isolation mechanisms, offer significant benefits over on-premise products. Okay, and that's for today. So thank you guys. Any questions?